So in our previous session, we have completed up to this transport layer part. We understood the functionalities of the transport layer. So 3 more layers are left out. So we have seen multiplexing, demultiplexing in the transport layer. Which voice, sir? Okay, so multiplexing and demultiplexing we have learned, where applications are recognized. If multiple applications are present, they will be recognized with the help of something called as port number. I have studied. Even if there are multiple applications that are present in system and there are multiple applications present in the server as well, then there are going to be 2 port numbers on the server side, 2 port numbers on the client side. I have explained you. So it depends on the number of applications that are running. If the number of applications are increasing, port numbers will also increase. It's going to be the same concept on client side or server side, doesn't matter. So I studied the segmentation and reassembly when the performance and the capabilities are not matching between two entities. They will exchange at what speed they must continue at how they have to perform the segmentation and the reassembly. They will talk to each other about it. Now, if multiple segments are sent from one side to the other side, if the other guy is going to miss some segments, he come back and he gives a negative acknowledgement. Okay, so once the negative acknowledgement is received, this guy is supposed to do a retransmission. This kind of additional communication that is happening between the component, between the layers, transport layers, is what we call as connection oriented mechanism. Okay, so that is what we have introduced so far. Up to what layer? Transport layer. Now we are going to see the remaining layers. Session onwards. So what does session do? First, dialog control. That's a technical name, but I'll explain you what is the real functionality behind it. Communication establishment in half duplex or full duplex. That will be decided by session layer. What is half duplex and what is full duplex means? Now that is half duplex, where only right now downlink is happening or uplink is happening, not at the same time. Either downlink or uplink. That means either you are sending the data, either your application is sending the data or your application is receiving the data, not at the same time. That's half duplex for us. Are you understanding? There is one more thing. Can happen at the same time. What is that? There is downlink, there is uplink. The transmission and reception both are happening at the same time. So your application is sending the data as well as receiving the data. It could do both the functions at the same time. Exactly at the same time, no issues. So that's what we call as communication establishment in half duplex or full duplex mode. All right, are you understanding this? Now, what is required technically in order to make this happen? What is required technically to make this happen? Tell me, what is required? I will explain you. If the transport layer has to deal with half duplex mechanism and full duplex mechanism, assume that we require a buffer for sending the data till to store the data till we send it out. We need to have the application or some particular protocol layer must have two buffers. What are the two buffers is about? One should be working as a transmission buffer, one should be working as a reception buffer. Your application layer must be working in a threading fashion. From software point of view, what is the meaning of a threading fashion? In a threaded way, multi-thread we call it as. That means it must be able to, your session layers logic or your application layers logic must be able to work parallelly. Transmission logic and reception logic must work parallelly. Assume that you have written a small program or small logic to work for transmission. You have written a logic, small logic for to work it as a transmission. Both the logics must be running parallelly in your CPU. And that too by using two different memory units, two different buffers, transmission buffer, reception buffer. Transmission buffer will have some information stored in it. You see, transmission buffer, which will be keep sending it out. Reception buffer is for the data reception that is coming from the other side. So we will have to maintain two buffers to deal with these two data that are ongoing and receiving. You need to have two parallel processes running. One is a transmission process, one is a reception process. Just visualize. You are a person who is present in an office. Your job is, your duty is to receive the items from which are coming in from the office. You have to send the items which need to be sent out. Assume that is your job. Now you can either only be responsible for one activity or both. If you are responsible for both, you will be maintaining two registers. One register for outgoing things, one register for incoming things. What is the procedure you have to follow for outgoing? What is the procedure for incoming? Now two things are happening. Two guys arrived. One guy came here for picking up some material. One guy came here to deliver some material. Now can you deal with both the things at the same time? You means here your office. Can your office deal with this both the things at the same time, or it cannot? For example, if there is a single person there, he can either take the delivery or he can either send the item out. Only one thing at a time. But in your office, if two people are working minimum, which is equivalent to two parallel processes, one guy can accept the incoming items, one guy can send the items out. You see, parallel thing is possible. Guys, one of you didn't mute your mic. Yes. Are you understanding that? Okay. Now, when the software is designed, it will be designed either in half duplex mode or full duplex mode. It would be designed. Depending on in which mode it is designed, it works out, basically. Okay. But whichever mode it is designed and decided, that mode only it will work. It can deal with that mode. But at the starting itself, between the client and server, communication has to take place. They must come to a conclusion about, oh, we should be working in this way. You see, we should be working in half duplex mode, where we should be working in full duplex mode. Who decides that? Which layer is having that responsibility to make such decisions? Session. How does session know? Nilima, you have any question? Okay. Have you understood that, guys? Session layer has to decide this. Also, session layer has to decide, has to set up a session, manage the session, terminate the session. What is the difference between application and a session? A application can be designed to have multiple sessions. So you can set up some sessions, you can manage the sessions and terminate the sessions for one application itself. For example, let us assume this case. Between your client application and server application, already relationship is formed. Okay. Now they can open up a new session. They can exchange something in that particular session, close out that session. Only session is closed. Nothing else is touched. What is the meaning of only session is closed? Again, your applications are still running. They might open up a new session as well. They might have a new session as well. So this, or you can, if you really like, too much confused about this session part, I will explain it in a easy way. Have you ever logged in into your Gmail and done the live chatting? What happens in a live chatting thing? When you are actually chatting with people on your Gmail, typically there is a possibility that you might have multiple windows opened up. You might be receiving multiple messages at the same time. Multiple friends are online and you are all talking, you're talking to them by using your chat boxes. There are multiple sessions in place. You see, multiple sessions, part of one single application itself. Okay. Opening the session. Now you visualize. You're opening a chat session. Manage it. Nothing. You need to maintain it. Terminate it. When you close it, when you say goodbye, bye, you will close that particular session because you don't need that anymore. You don't need that box anymore. Just imagine like that. That's the kind of thing I'm trying to make you visualize. That's all. Session setup, session management, and session termination. Okay. So a session can be established multiple times. Multiple sessions can be running parallelly within an application. There can be anything that is possible. To establish all these things, to manage it and terminate it, who is responsible for it? Session layer is responsible for that. Okay. Synchronization. So these two features, communication establishment in half duplex mode or full duplex mode, that communication that is happening as part of which session? Okay. Deciding that between the client side and the server side is what we call as dialog control. So session layer will do a dialog control at the starting. Both the session layers will come to a conclusion. We will work in half duplex mode. Whatever the information we are exchanging is part of session number 1. Or maybe they can also create a session in the middle. We are establishing an additional session now, which is going to work in full duplex mode. It might happen that way. You see, actually it's called a session layer, right? It should be meaningful. Okay. Checkpointing. As part of the synchronization procedures, session layer will perform an activity called as checkpointing. What is that checkpointing? Any guesses? You're going to download a movie, 4 GB movie. You are using a normal desktop which is not having any power backup. Now 99% movie is downloaded, power failure happened. What happens now? When the power resumes, when you resume your system, that 99% voila is gone for a toss. Why? It's not complete. The file is not complete. You cannot play that. When at the time of session resume, if session cannot resume from wherever the failure occurred, now what need to happen? Whatever that 99% file that you have downloaded is waste of time and waste of bandwidth. Your file download will start from 0 bytes once again. Okay, again all the 4 GB data will be downloaded. So what is checkpointing here? When the application data is arriving from the higher layers, session layer might include a checkpoint at every juncture. At some point in time, we will keep adding a checkpoint. All right. Now, what happens if a failure occurs? If a failure occurs here, if the receiver detects that it's a failure occurs here, you don't need to go back to the starting. You will have to go back to only previous checkpoint, because if wherever the checkpoint is received, till that place the data reception is complete, till that place the data processing is perfect, you never need to retransmit that part once again. Only if at all you need to go back only to your previous checkpoint. You see, meaningful, right? It makes sense. Understanding it? Now normally if you want to visualize it, how do you visualize it? You have these download softwares. Have you ever installed any download software anytime in your PC? Movie download softwares or file download softwares. What will happen? They will keep showing you progress. Even if the power is down, when they come back, when the power resumes back, file download will happen, but it resumes only from where it has to resume. It doesn't start from 0 onwards. You're understanding that? How that is possible? Because of this checkpointing. So if the failure happens in the middle of something, you will have to go back to only your previous checkpoint. That's all. You don't need to start from scratch, start from the first. I hope you are visualizing the situations here. What is the responsibility of our below 3 layers? Delivery, network layer, data link layer, and physical layer. If physical layer is bringing the problems, then data link layer will solve it. Some data link layer problems, network layer will solve it. But all the 3 layers together, they will do the delivery. Application is generating the data. Huge data it may generate. But while you are sending the data from one side to the other side between the computers, they started facing a lot of issues. So they have started solving those issues. They started implementing solution for each kind of a problem they are facing in one layer. Right now, you will be able to visualize what is happening. When there is a huge file that is being sent, when the checkpoint is not there, if there is any failure occurs, now you have to go back to the starting position, which is a troublesome thing because you need to retransmit everything from the scratch. But when the checkpoints are there, you know that till this checkpoint everything is successful. You need to go back only to the checkpoint. You don't need to go back to the scratch. So these are the problems that they are solving in a live data transfer scenario. Implemented that mechanism in which layer? Session layer. This mechanism is implemented in. I have told you these 3 layers, presentation layer, session layer, and transport layer, are doing some activity called as processing. What is the meaning of processing? What is the meaning of processing? This sort of things is processing the data. See, data arrived from the higher layer. How you have processed it? How you have processed it? You have added a clip everywhere. You have added a checkpoint everywhere. You see? The checkpoints are there in the data that is generated by your application or not? No. Who are adding it? Session layer is adding it. That means additional things you are attaching to your data or not, which will be considered as Processing, yes, it is processing. One food manufacturing unit is there which manufactures the bread. Normally, this size bread will be generated in your in the unit. After that, bread is basically like made. Normally, what do they normally do is they will actually cut it into small pieces and then they pack into a into a beautiful packaging. They'll cut it. Why do they cut it? Whenever you eat the bread, you don't want to eat the bread as a single piece. That's one reason. Second, it will be easy for you to eat. Basically, that is the reason only. If they cut it and keep it, you don't need to cut it at your home. Instead of that, you will be having that will be ready for direct consumption. You see, that is the meaning of processing. Okay, so this is also processing, checkpointing. Synchronization of data generated by multiple data sources. There's a cricket match ongoing. Now there are two inputs. One guy who is capturing that video, he won't be speaking anything. He is not the commentator. Only that video will come to our, will have to come to our machine. If you are watching a live cricket match on your PC, video will come from here. Audio will be coming from your commentator. It is not generated at one source. Now audio is generated at one source, video is generated at one source. It should be perfectly synchronized in such a way that the play at your receiving side should be perfect. You should not have gaps between video and audio. You should have perfect synchronization there. Otherwise, what will happen if video is happening at one time, audio is happening at one time? Okay, so you won't feel good. That will not be like a good experience for you, you see. It causes an issue for you. Okay, so synchronization should happen when the data is generated by multiple sources. Who takes care of this kind of responsibility? Session layer. How it happens? I'll explain how it happens. Simple. If this guy attaches a live time parameter, this guy also attaches a live parameter at the session layer level. The receiving session layer, based on the time units attached, timer values attached, it will be able to sync up. It will be able to play it correct time. Visualize this. Audio is a very small size data, whereas on the other hand, video is going to be a very huge information, which takes more time for receiving at your PC. Audio takes more time or video takes more time? Definitely video takes more time. But irrespective of video takes more time or audio takes more time, if you wanted to have a perfect synchronization, what do? It attaches a time. Right now, the time is going to be this. 8 o'clock, 30 minutes, 15 seconds, 235 milliseconds, 220 microseconds. The timer is attached by this voice generated session layer, this video generated session layer. The time will be generated to one video frame, one audio frame. Multiple video frames are arriving, audio frames are arriving. When they arrive at the destination session layer will play the audio frame and video frame which are having the correct times matching. He will play that. Visualizing that. Are you understanding that point? So that details will be added at you by which layer? Session layer, used by the session layer to do the perfect synchronization. So I've understood session layer functions. Only two functions we have: dialog control, synchronization. Under dialog control we have two things: session setup management and termination. If your application is What type? Multiple session type. Your application is. Okay. And exchanging information related to work either in half duplex mode or in full duplex mode. Synchronization is adding checkpoints and synchronize if the data is generated with multiple sources. Great. We are hitting presentation layer next. So what is its responsibility? What is its functions? Coding and decoding. What's the meaning of coding and decoding? If application generates data, it will be in English format or some format. It can be any language, you don't know. Like it can be Hindi also. When you are typing Hindi, it will be Hindi. Application generating Hindi language. So what is coding and decoding? The data that is generated by the application can be converted into the data that is transferable. Basically, transferable format is always binary. So who converts it? Two choices. Application layer himself can convert it, or that job can be given to presentation layer. Either presentation layer will do it or application layer will do it. One of the two layers will do it. Which layer must to do? There is nothing called as which layer must to do. Any layer can be done. It depends on the implementation we choose. Can be done by application, can be done by presentation. Any which one is okay for us, but somebody should do it, because we cannot transmit anything other than ones and zeros. All the information that is generated by the application, whichever language it may be, at the end of the day must be converted into binary data. All right. And vice versa. Reverse, if data is received, should be converted into from binary data to the normal format, should be converted. Compression. Compress big data into smaller size is going to save your bandwidth. That means first data is taken from the application, converted into binary. You have generated 4 lakh bytes of data. Okay. Now the total data available is 4 lakh bytes. What is the next activity presentation layer will take up? Compression. Compress the data into smaller size. Maybe if you compress it, 4 lakh bytes may become 2,80,000 bytes. What happens? Now 1,20,000 bytes is going to be your saving. You don't need to transmit the total 4 lakh bytes. You will be only transmitting compressed bytes, which is 2,80,000 bytes. It will save time, it will save bandwidth as well. You see? But how this compression works out? Any idea? It's an easy method. Normally compression works out in some 20,000 bytes of file is there. Inside that 20,000, not bytes, bits you take. 20,000 bits are there, ones and zeros. Normally what compression software will do is this. It will try to find any patterns, if there are any in that binary data. Patterns. What is the meaning of a pattern? Some 200 bytes of data which is getting repeated some 10 times. It will try to find that. Some 200 bytes of data which is repeating 10 times. What the compression software will do, if it finds out 200 bits of data is repeated 10 times, it will remove that 200 bytes from that particular position. It will remove. Then it will note down information with the help of header. What information it will note down? I have removed these 200 bytes from so and so location. 20 locations I have removed it. it will note down the location information. To note down that location information, you may require only 8 bits. Assume 200 bits you have removed it from 10 places. How many bits you have removed? 2000 bits you have removed. You have noted down that 200 bits in the header, plus you have noted down positions. How many positions? 10 positions. Each position requires 8 bits. 10 positions, 10 into 8, 80 bits. So 2000 is removed. Out of it, you have noted down the 200 bits in the header, plus positions is 80 bits. 280 bits. 2000 is removed from your data. 2000 minus 282 bits that you have noted down in the header about this particular pattern is repeating in which positions. What is your saving now? 2000 minus 282 that you have noted down in the header, which is going to be around how much? 1720. So 1720 bits will be your saving out of that 2000 bits. So your file size is 20,000 bits. In 20,000 bits, how much you have saved now? 1720 bits you have saved. That much you have compressed your file by finding out the pattern. You know what is the meaning of a pattern? Same bits of data, 200 bits of data repeated, which is a pattern repetition. Are you visualizing it? How many more patterns you find, that much effective your compression will be. If you find out another 200 bits pattern is repeated 8 times, another 200 bit pattern is repeated 4 times, another 150 bit pattern is repeated 6 times. Like that, if you find more and more patterns, you remove all these pieces, note down that information in the header, which places this pattern need to be repeated. Once it goes to the receiver, how the receiver do the decompression? He has the pattern information, in which positions it must be replaced. He has that information. He will start replacing it in those positions. Original file will be generated. You understanding that point there? So compression is going to be useful for saving your bandwidth and time while transmitting the data from one side to other side. Is it processing or not? You are traveling. Airlines guy has only told that doesn't matter how many kgs it is containing inside, but only one bag. So what do you do now? One bag with so and so dimensions, he has told you. What do you do now? You definitely need to carry more information, more clothes and all that. What do you do? After you pack some clothes, you sit on that. Okay? So after it is got compressed, you will try to put some more things. You see, basically, if you put some weight, all, it will be compressed. You will be able to push in some more items into it. You see? You don't have a choice now. Cannot carry another bag. Compress it. Same thing. But here it is going to be much more logical because this is data compression, not a cloth compression or something. Data compression should be done in a logical way. Encryption. So presentation layer is responsible for encryption, meaning converts application data that is generated into a secret format. Why? What is the reason? Why we are converting it into a secret format? So that even if somebody in the middle captures it, they won't be able to read what is it. For example, right now I am actually having a private meeting with one particular person. I'm speaking and that particular other guy is listening from US. Somebody wanted to listen to my conversation. They have just climbed on top of my building. They have recognized which is the LAN wire coming out of our building, my office. They cut that wire into two pieces, connected it with a T-jointer. Okay. So T-jointer will have 3 units totally. One wire they will take it to their computer and use that some automated softwares. They will connect it to that computer. All the data that is going on the wire will be captured by this software, because the data is coming on the third wire also from the T-jointer. They will be able to convert it into meaningful information. They can play it, so they can easily find out what I am speaking to that third person. They can easily find that out. You see? When it is possible, if the data is not encrypted, if the data is encrypted, converted into a secret format, only the receiving guy can decrypt it. None of the middle guys, even though they capture the information, it is useless for them. They don't have perfect details to decrypt that information, decrypt that data. They cannot decrypt. Nobody in the middle can decrypt. Only the receiver can decrypt. So if you are opening a bank website, if you send your username and password, who will receive that username and password? Only bank server. Middle guys won't be able to read that username and password of your bank website. If middle guys reads that, that's it. You are gone. Why? They'll use your username password. They'll start transferring money or whatever. You see? They could do anything. They can use that private information for any purpose. You can't tell. So what is this? Data is secured in encryption case. So presentation layer functions can also be optionally implemented in which layer? Application layer. As I told you, that all these functions can be implemented in application layer as well. Now it's a choice. Not only presentation layer functions, guys, even session layer functions also can be implemented in application. Now what happens? If presentation layer functions and session layer functions are implemented into application layer, then we call that as 5-layered architecture. How many layers we have totally introduced? 7 so far. Out of 7, if application, presentation and session layer functions, all the functions are implemented by application on its own, now it is equivalent to 1 layer. Application is equivalent to application plus presentation plus session. That's 1 layer only. So totally how many layers we have? Application, immediately we have transport, then we have network, data link and physical. How many layers? 5 layers only. That's called as 5-layered architecture. When it is going to be termed as 7-layered architecture. When it is going to be termed as 7-layered architecture. Simple. When presentation and session are implemented separately, not part of your application. And they are not part of your application, they are separate. It's now 7 layers. Application is separate, presentation is separate, session is separate, transport, network, data link and physical. 7 layers we have. Are you visualizing that? I'll explain more about that in the coming slides. We will understand it. So what is the duty of the last layer in the architecture, application? What is it going to do? It's going to deal with generation of data. But how? Independent data generation. You can write a software program which can generate the data on its own. Yes, you can. You can write a software program like that. I can design a HTTP application which generates the HTTP web pages on its own. You are connecting to Google server. Google web pages are coming to your machine. Google web pages are coming to your machine sent by Google server's application. At Google server side, there won't be any human being who is typing some information to send you the web pages. Already that web pages are designed and kept into your application. Application immediately will send you that web pages. It won't be like um, it won't be like taking the help from the humans. Our applications can take the input from human. R and end, what is the meaning of it? Either application can generate the data independently, or it can take the input only from human, and means some data it can generate, some data it can take the help from human. R and end with the input from another software program. One software program, one software application can take the data from some other software program, some other software application as well. Again, R and end. What is the meaning? See, one application can generate the data with all the three combinations possible. Some data is generated by that application, some data is taken from human, some data is taken from another software program. Mix it together, you are generating some piece of information, sending it to the other side. You see, that possibility is there. Or any independent thing also can be done. What is the meaning of it? Some applications only will take the data from humans. They don't do anything on their own. They don't generate the data on their own. Only take it from humans. WhatsApp application is there. WhatsApp application take the data only from human or not? In which cases it takes only from human? If you are generating a message, you are typing a message and pressing the enter button, what's going to happen then? Message will go to your friend. Who is generated that message in WhatsApp application? We humans. But you have to look at that carefully. When the message goes to the receiving side, time also will display at what time that message has been sent. Okay. Now you see, half information is human input. The time information is, you are not inputting the time. WhatsApp application is reading the live time from the mobile phone software, and then he is attaching the details. Are you understanding that? So are you understanding the difference now? Human input, some is on its own, taking it on its own. Okay. Sometimes it can take the data from another software program. What is that? You have a camera, you have a WhatsApp. Camera is a different application in your mobile. WhatsApp is a different application. But from WhatsApp you can use camera, take a photo and send it. Now you link here. Here input is generated by which application? Camera application. You have invoked camera application from WhatsApp by clicking on that camera icon inside WhatsApp message thing. Then you took a photo. Okay. That photo is now given as the input to WhatsApp. Now what is camera? Everything is application from your mobile perspective. So that is a separate software program which is giving input to our WhatsApp. It is what it is giving as the input. Live picture. It is giving as the input. Which is sent by who? WhatsApp. But you see, while sending the photo, you can add some text. That is what? Human input. So software program is the photo. Human input is whatever the text that you add, plus some data WhatsApp might generate on its own. What is it? Time. It will attach on its own. You see, these three details are there. Okay, together that is one single big data unit which is carrying three pieces of information in it. But all of it together we call it as data. What is all of it together means? What is data from WhatsApp point of view right now? Photo, text, time. All the three things together, only we call it as application data. Which is that application? WhatsApp. That is WhatsApp data, which will be sent from client to server. Are you guys clear? Understood that? Provides services for human or program. Provides services for human or program. What is the meaning of service? Out of all the layers that are present, the only layer that will be providing service to human is application. What about the rest of the layers? What about the presentation layer, session layer, transport layer and all that? No. Presentation, session, transport, network, data link and physical services are going to be used by application. Application provides the service to human or a program or a software program. It will provide the service to. Okay. But we directly take the service from application. Application may use the services of the other layers. That's a different story that we don't need to consider and pack it inside this. Are we clear with that? Now we are going to look at all the layers together. Here we learn the most concept. So we have how many layers here? 7. That's the path it travels in. Application generated 10,000 bytes. Now what need to happen to the 10,000 bytes, guys? What are the next 3 layers going to do? Processing. Next 3 layers are going to do. The below 3 layers are going to do the delivery. What processing? Presentation layer has encrypted the data 10,000 bytes. Output will be 10,000 bytes. But what is the difference between this 10,000 bytes and this 10,000 bytes? This is plain English and easy format, which anybody can easily understand. But these 10,000 bytes are encrypted, converted into a secret format. Only the receiving I can decrypt it. In the middle, even if somebody captures it, they cannot. Then the 10,000 bytes is going to be compressed to how much? 8,000 bytes. So what has happened? Compression worked out, 2,000 bytes of saving. You compress the data. So how your application data has processed so far, has been processed so far. The original data has been converted into a secret format. Also, it is been compressed. Processing occurred or not to your original data? Yes. Then what session layer is going to do? He may be adding 2 checkpoints at 4,000 and 8,000. 2 checkpoints he is adding. Okay. So after sending 3,000 bytes, if any error occur, we have to go back to starting again. After sending 5,000 bytes, if any error occur, we need to only go back to what point? Only up to 4,000 we don't need to retransmit from 0 to 4,000 again. If at all we need to start the retransmission, we need to start it from the previous checkpoint. What is it? 4,000. You understanding it? 2 checkpoints added by the session layer. Hello? Guys, any audio problems? Anyone facing?
No, sir.
Okay.
No, nothing like that.
Okay, thank you. All right. So it's going to add two checkpoints at 4000 and 8000. Fine, great. Then what transport layer is going to do? Divided that 8000 bytes of data or 8000 change bytes right now. So it's going to be dividing that data into 8 segments. Each segment will be typically how much size now? Approximately around 1000 bytes, little more than 1000 bytes. Why it is little more than 1000 bytes? Presentation layer header is something, session layer header is something. Together it might increase the size a little bit, because I told you that every layer will include some header. Okay, so it is definitely going to be 8 segments. The size is typically around somewhere near to 1000 bytes. But how many segments? 8 segments. Great. Then what happens? These 8 segments will go into network layer. What network layer is going to do? Is going to keep 8 segments into 8 IP packets. In one IP packet, it is going to add IP addresses. It will add the IP addresses for each packet. You have to send one after the other. How many IP packets you are supposed to send out? 8 of them you will be sending. Okay. Data link. Each IP packet is going to insert into one frame, data link layer. Totally how many frames it is going to generate? 8 frames. And he is going to send that 8 frames by adding the MAC addresses. Whose MAC addresses your data link layer will add? Either the destination computer's MAC address or router's MAC address, depending on if the destination computer is present in same network or not. If it is present in a different network, what will happen? Your computer is going to attach router's MAC address so that your IP packet will be sent to router. Okay, but 8 IP packets must be kept into 8 frames totally. 8 frames will be sent one after the other. Each frame will arrive at physical layer. Physical layer will keep sending out the bits of every frame, 8 frames in a sequential fashion, frame after frame. First frame is about somewhere around 1100 bytes, assume. Okay, 1100 bytes means 8 bits, no? 1100 into 8, which is going to be how much? 8800 bits. Physical layer will be sending out 8800 bits. After sending 8800 bits, physical layer will give a gap of 12 bytes. It will give a gap. Then again he will send next frame, give a gap, next frame, give a gap, next frame. Like that he keeps sending it out. Are you understanding that? Physical is going to do that. So what happened? See the total processing. Where the processing occurred, how many layers? Below 3 layers there is no processing. Processing is happening only in the middle 3 layers. What are those? These 3 layers. Encryption occurred, compression took place, added the checkpoints, then divided the data into segments. 8 segments. Each segment has been kept into one IP packet. It's like you have generated 8 letters, kept in 8 covers. For each cover, you are going to attach a separate stamp, separate from address and to address, because you have generated 8 covers. You see? So these 8 segments are like 8 pieces of it. which is going to be kept in one cover. For each cover, we are going to attach a IP address. Then after adding the addresses, you send it to data link. It will generate 8 frames exactly, one for one IP packet, and it is going to send out those things either to the destination if it is present in the same network, or to the router depending on where the destination system is present. Physical is only for transmission of the bits. So what happens on the receiving side? Reverse in the receiving side. Receives the bits of 8 frames sequentially. One after the other, 8 frames will be sent to data link. He separates the frame header, extracts 8 IP packets from that. Header will be removed. What is the reception guy's job? Removing the headers. Once the headers are removed, it's going to forward to network layer. Network layer extracts how many? 8 segments from 8 IP packets. From one IP packet, if you remove the header, if you basically like cut the cover, from inside that one segment will come out. So how many segments will come out? 8 segments. Segments will be forwarded to transport layer. What transport layer is going to do? Reassemble those 8 segments and form 8000 bytes of big data. 8000 bytes is going to reassemble, generate the original unit. Those 8000 bytes will be forwarded to session. Session will do the checkpoints, will verify the checkpoints. Okay, checkpoint is at 4000, 8000, everything is clean. No problem at all with the reception of the data. I don't need to go back to any previous thing. Everything is clean. Well, then what is he going to do? He will forward, by removing the checkpoints, he'll forward the remaining data to presentation. What presentation do? First, that 8000 bytes will be decompressed. Once the decompression is finished, how much data will be generated? 10,000. The 2000 bytes will be re-added. It will be whatever that is compressed. Then decryption will take place. 10,000 bytes is not in normal format, it is in secret format. What is the job of the presentation layer? Convert it into normal format before it is sent to application. Okay, so he converts it into normal format. Decryption took place. Then the decrypted 10,000 bytes is forwarded to application. Application received that 10,000 bytes. Is that clear, guys? Understanding it? Okay. So have you got a clean idea of what is these 7 layers in OSA about? Okay, and what do they do? 3 layers will do processing, 3 layers will do the delivery. Now, the last points or the last section that we have to discuss is this. So we know the number of layers that is present in each component. In the system we have 7 layers. In the switches and routers, we are going to either have 2 layers or 3 layers because they are only responsible for delivery. Only delivery layers will be there. That too dependent on local delivery or network to network delivery. If it is local delivery component only need to have 2 layers because it is only dealing with local MAC addresses. Okay, it doesn't need to deal with IP addresses. But your network layer will have 3 layers because it need to read network layer address to send the data from one network to another network. It will have 3 layers. But one thing is very clear and clean. What is that? One thing is very clear and clean. Transport and above are present only in the client and server. Meaning is what? These 3 layers, what they are performing. See, application is definitely present only in client and server. Now I am telling you processing is also present only in the client and server. What is the meaning? Processing and reverse processing is only possible in client and server. The middle units, your switches and routers typically they won't do any kind of processing. There are some, of course, exceptions, and sometimes the middle components also will do some little processing. What is that? Why is that? I will explain you later. But the major processing that happens is which place? These three layers: presentation, session, transport. If this presentation encrypts, this presentation decrypts. None of the middle places we don't have the presentation layer. So nowhere decryption take place because presentation is present only here and here. Okay. If this transport layer is doing the segmentation, this transport layer will do the reassembly. He's divided the data into 8 segments. He is going to reassemble those 8 segments into one big piece. Are we understanding that? Okay. So the biggest question that comes into our head is this: if these 3 layers are present only in client and server, if they are not present anywhere else, can't we combine all these 3 things already into application itself? Can't we make it one single layer? Because they should be only present in client and they should be only present in server. Nowhere else they need to be present. Can't we combine it? What do you think? Can't we generate one single software which can do the job of I have already told you this example, right? I've already told you application presentation session can be combined. If you combine those 3 things, it's equivalent to a which model? 5-layered model, because these 3 things together we call as application layer. These 3 things we call it as application layer. Okay, can't we combine transport layer also into that, and can't we make your application, your total architecture into only 4 layers instead of 5 layers? Can't we combine transport also into this thing? If already we are combining 3 things, if that is possible, combining 4th thing is not a big deal. There is no restriction that we should not combine. We can combine. Software wise, there is no problem. We can combine. But why they have kept transport layer always separately? Why they haven't included into this kind of mechanism? I will explain. Transport layer protocols are standardized. Like there is a protocol called as TCP, UDP, IP, SCTP. Most of the times, these protocols only we use in any system. Because these are become very popular protocols, all operating systems like Windows, Linux, your Apple Mac operating system, all these operating systems already have implemented TCP mechanism, UDP mechanism, SCTP mechanism in their operating system itself. Already the mechanism is already present. If the operating system is already providing you that functionality, are you mad or what to do the same, write the same software, the same logic and everything in the form of a software while you are developing your application? Do you want to rewrite that whole logic once again? Not needed. Why? Because that software is already providing the functionality which is present in your operating system. We can use that. You see? You can use it. You don't need to redevelop that. Are you understanding it? What happened? There are popular transport layer protocols developed. They become so famous that they are present in every operating system everywhere. We don't need to rewrite that. We can use them already, whatever that is present in your operating system. Because of that only, most of the times transport layer functionality won't be included into your TCP, won't be included into your application. Okay, software. Application software won't contain transport layer logic that is present separately. It is present separately in your operating system. We just use its services. You don't want to drive in very heavy traffic roads because you are becoming really bad about driving in your city. So you can afford a driver. You put him basically to drive. Basically, you have employed a driver. After you employ the driver, what do you normally do? Sit back and do your stuff. Maybe open your mobile. Maybe talk to somebody, send some messages. Whatever you want to do, you do. Driver will be driving, isn't it? Because you already given the job to him. So the transport layer protocols are already standard protocols are already developed and kept in operating systems. If they are already present, why do you want to develop that logic once again when you are developing your application? But most of the times, the presentation layer mechanism and the session layer mechanism that application wanted to use, application may choose its own mechanism which are not standardized. Okay, when application is not choosing the standardized presentation protocol, standardized session protocol, what do? They will develop presentation logic and session logic inside your application itself, so that application will contain all the three things on its own. But if application has decided to use standard presentation layer protocol, standard session layer protocol, standard transport layer protocol, then what happens? Only they'll develop application logic separately. Then we have a presentation layer working, session layer working, transport layer working. It all depends on what? Whether you are choosing presentation layer software to be working separately, or you developing yourself. It all depends on that. If you develop this whole logic yourself, it will be considered as one unit. That is one layer right now for you. Understanding that? Now, one question has been asked at the starting of the sessions, which I need to answer now. How do we know that on the receiving side also same protocol will be used? Was the question asked. What is the guarantee that if we are using on the whatever the protocol we are using on the sending side, the same protocol must be used on the receiving side? What is the guarantee? How it should work? I'll explain that now, because I've told you this story. I'll explain you that in an easy way so that you will understand. Assume that your application is HTTP. Presentation and session are not there. Imagine that presentation session are not present. How many layers I am going to take right now? How many layers I am going to take? 5 layers. Application. Directly then I am going to have transport, network, session, data link, physical. What happened? 5 layers. Okay, fine. Application is which application? HTTP. Hypertext Transfer Protocol, which is used for web pages. Normally, typically HTTP uses TCP protocol. But what does TCP protocol will do is, in its header, it will note down a port number called as 80. Port number 80 is a reserved port number for HTTP. The receiver knows that receiving TCP layer receives any TCP data. Inside that, if he sees the port number as 80, he understands that inside this the data present is HTTP protocol. He knows that with the help of protocol, port number what? 80. Great. When this TCP data comes to IP, your network layer will note down protocol number as 6. Protocol number 6 is reserved for TCP. In the IP layer is noting down the information that is coming from the higher layer is TCP. It is noting down. When this IP packet is being inserted into Ethernet layer, Ethernet is going to note down a type field value 2048. This 2048 meaning is IP. Okay? That means 2048 is a number reserved for IP protocol. Physical layer is just bits. Okay? Now bits are transported to the receiving guys. I will explain you what will happen on the receiving physical. He receives the bits. The Ethernet layer receives the Ethernet frame. Okay? Now listen to this carefully here. I have told you that every layer may contain multiple protocols. Accept or not? Yes. In the network layer, assume that there are three protocols: IP, AppleTalk, IPX, something like that. Some three protocols are running in network layer. Okay. Now, how does Ethernet know to which protocol the data must be given? There are three protocols running on the receiving computer. How the data will be given to which protocol it will be given to? It will definitely be given to which protocol? IP. Why? Because in the Ethernet header, the type field used is 2048. That is representing what? That is representing IP protocol. That means Ethernet knows that there are multiple protocols running in network, but he will send the data to which protocol? He will send the data to IP protocol. How come? Because he knew that the data present inside is IP. How does he know? With the help of type number representing 2048. If it is a different number, it will send to a different protocol. Okay. Now the data is received at IP. Now, in the transport layer, there can be many protocols. TCP, UDP, SCTP. There can be many protocols present in the transport layer. Tell me, how network layer will give the data to which protocol, which transport protocol? It will give it to TCP, UDP or SCTP? TCP. How come? In the IP layer header, there is a field called as protocol. That protocol is representing 6. That 6 is a reserved number for TCP. Okay. So what does this IP layer do? He says that, hey, UDP, SCTP, don't expect anything from my side. You guys take rest. I am giving the data to whom? TCP. Because protocol number that is present is 6. I am giving it to TCP. Now, TCP, on top of TCP, there can be many application protocols running in your computer, like HTTP, FTP, SMTP. There can be lot of other protocols, etc., etc. There are many protocols running on the receiving computer. Many application protocols are there. Many applications are present. Now TCP gives the data to which application? TCP will give it to HTTP. Why? Because port number 80 represents HTTP. So he won't give it to FTP or he won't give it to SMTP. He will forward that to HTTP. If HTTP application is not present in the receiving computer, it will throw that into dustbin. It will send a negative message back to sender. Hey man, that application is not there. I cannot send the data to application. I am sorry. Because you try to send the data to port number 80. Port number 80 means HTTP, I know. But there is no HTTP application running on my computer. I cannot give the data to application. I am sorry. I am throwing it into dustbin. He will send a message back to the sending system, sending TCP. If that is not present, if that application is not present, okay, so the data will be delivered to which protocol? HTTP, out of the many protocols that are present. Are you visualizing that or not? Are you understanding that? Okay, so There, whenever the data is getting exchanged between two systems, there is a clear-cut indication from sending system about which protocol is being used in which layer. That information always will be noted down by lower layer. What is the meaning of lower layer? Which application data is arriving will be noted down by TCP. Which transport layer is sending the information will be noted down by IP. Which network layer is sending the data is noted down by Ethernet. When the Ethernet frame is sent with the help of physical cable, it will be received in the Ethernet layer on the receiving side because it is a Ethernet cable. It will go to Ethernet protocol. Ethernet protocol will detect that the protocol, network layer protocol present inside is IP with the help of this. He will send it to IP. Network layer protocol will tell inside this TCP data is present. TCP protocol will tell that inside this HTTP data is there. I will send it to HTTP protocol. Linking is that. Are you getting that point clearly? So whatever the protocols that are working on the sending machine, same protocols must be existing on the receiving side. It must be. That is a mandatory step. You can't escape from that. Okay. Now you see how the data is arriving. Application data sends to presentation. Presentation will note down what? Yeah, you can use any medium to transport the data, not only Ethernet. You can transport it by using even you can transport the data by using even this thing called as optical fiber or many other methods. PPP, frame relay, ATM, there are a lot of things are there, which we will discuss in the data link layer. Don't worry. Our next topic is that we'll do practicals also on that. Okay. So data link layer, we start studying it, then we'll understand everything cleanly. Now, application generates the data sent to presentation. What does presentation do? Presentation layer will definitely attach a header. Header about what? Come on. Header about how it encrypted the data. It might attach a header. How much it has compressed compression relation information it might attach. One additional thing you might also attach in the header is from which application I have received the data. You might note down that. Which application protocol I have received the data. Sent to session. Session layer will note down which presentation layer protocol I am receiving the data. Session layer will attach its own headers like checkpoints. Okay, if required synchronization, timing related information, all those details will be attached by session layer in the header. Session layer send it to transport. What does transport layer will do? Transport layer will note down from which session layer protocol I am getting the data. That it will note down in the header, and also it will note down is parts like session layer, transport layer will attach sequence numbers. For each segment, he will attach one sequence number. Okay. So he will be noting down his own details, sequence numbers, and when the data is finishing. These kind of details will be noted down by transport layer in its header. Also, he will note down from which higher layer protocol it is getting the data. Okay. Next, send to network. Network will note down from which transport layer it is, from which transport layer protocol it is getting the data. IP will note down its own header fields like what? IP addresses he will attach. Addressing information. When that is sent to data link layer will note down from which network layer protocol it is receiving the data in its header, plus it is going to attach its local addresses called as MAC addresses. It will attach. Okay. Then sent out of physical. Received by switch. What switch will do? Switch receives the bits. What switch is going to do? Switch is only interested in the data link layer header. He is not interested in network and above. He don't care which network layer protocol is present inside, which transport layer protocol, which session, which presentation, which application. Switch don't care. Switch is only concentrating on which headers. Only data link layer header, which is your Ethernet header, your MAC addresses he is interested in. Why? Because switch is connected to many machines. You need to decide to send to which machine. He will be only deciding that. You getting it? Then after reading the header, he receive it from one physical link. He will be sending it out on another physical link. He will send it out. Incoming is one link. Outgoing is one link. Imagine this, one switch is there connected to two computers. Traffic is coming from one computer to switch. Switch will send it on other computers wire, right? It another physical link. But by reading the header in the middle, he does that. That's why how many layers it is having? 2 layers. But network layer will have 3 layers. When he receives any frame, he will extract IP packet from that. And from that IP packet, what is he going to do? He is going to open that IP packet and read. Which part? Header, addresses. Then he decide, okay, I need to forward it to so-and-so network. He will then put it into a frame, then forward it again. Again, switch will only be taking care about data link layer level. He will only read MAC addresses thing. Sent here. Finally, IP packet has reached the network layer. What does the network layer do? Network layer is going to send the data above. All these guys will do the reverse processing, then the data will be sent to application. Now, if you look at it as a order, this is how it works out. It comes below, it reaches to the layers depending on the component functionalities. Okay, then it reaches the destination, all the layers will go up. Understanding that? So we are now going to start in our tomorrow's class from data link layer protocols. The first one we are going to hit is Ethernet. We learn with practicals and all that, we start learning this Ethernet protocol. Once we started studying these protocols, then we'll understand how the whole thing is really working out. Okay, clean. So all these protocols we'll cover as part of our OSI sessions. So that's all for today. So